Okay, so if you have chemical A, then they all exist as particles, right?
Yeah.
Yeah, that question of what is particles, right? When is it particle? When is it not particle? In all
Wow.
cases, they are all particles, lah. Then they can have atoms. Oh, if it's a monoatomic substance, then you can have atoms. If you have a compound, you get molecules. If you have an ionic compound, you get ions.
Okay.
Like that, right?
Wow.
So you can put them together, then miraculously you'll get C,
See? Then.
that kind of thing.
Oh.
So if that happens, that means a chemical reaction takes place. But the thing is, when you pour two substances together, it doesn't mean that a reaction will always take place. You can pour them together and nothing happen, and then it just sit on the desk.
Oh, that's just like a mixture, right?
Yeah. So when you have this collision theory, they tell you why a chemical reaction will take place successfully instead of forming mixtures. So you can have substance A and substance B, you pour them together, then they all go into the flask. You remember particles, they are always in constant random motion.
Yeah.
So they will move in that solution, right? Whether you like it or not, they will move and you cannot see it.
Okay.
Yeah.
So
So the thing is, when they move, they will bang into each other.
yeah.
Collision theory will tell you that if the two particles collide with a certain amount of energy or the minimum amount of energy for a reaction to take place, then a reaction will happen. Then if they collide with each other, but they don't have the minimum criteria, right, which is the minimum amount of energy, right, then the reaction won't happen.
I see.
So that minimum amount of energy is called activation energy. So activation energy is the minimum criteria for your chemical reaction to take place.
So this activation energy, is it come from the particles themselves?
Yeah, it comes in the particle themselves. Why the particles have that energy is mostly because of the surrounding temperatures and stuff.
Oh, like if you heat it up, then they got more energy.
Yeah, because that is KE, movement.
Yeah.
KE. So if they have a sufficient amount of energy from their movement, then can lor. And you also know that solid, liquid, and gas particles, they all have energy, right? The solid ones, right, they have very low amount of energy because they just sit down there and vibrate on the spot.
Okay.
So sad, right?
Yeah, compared to the rest.
Then the liquids, right, they can slide over each other, they can move a bit, right? Then the amount of Ke a liquid particle has is higher than the solid. Then the gas, right, they fly everywhere.
Yeah.
So that means gases have the highest amount of energy.
So they are most likely to
A particular reaction will have a minimum criteria. So certain reactions have lower criteria, so the energy you need for the collision is lower. Certain reaction, the criteria is higher. So that even if you have two gases, you put them together, they will collide, but they might not hit the minimum criteria.
Oh, so it's like different
reaction, different criteria.
reactions. Okay.
If not, we get like chemical reaction in air all the time. So scary.
That's true. That's very true.
Imagine the oxygen and the nitrogen colliding with each other all the time. Then you'll see reaction all the time on top of you and
Very
surrounding you. You're
dangerous.
gonna burn your hand and all that.
That's not
Yeah.
nice.
So this is the whatever I was talking about. So the colliding particles, right, with less than EA, right, which is less than activation energy, right, they will just bounce off each other after colliding with each other.
Oh, okay.
So when that happens, no new product is formed, and you call that reaction, the collision, an ineffective collision.
So it just doesn't combine.
Just doesn't combine. Useless. Not effective, the collision.
I see.
Yeah, because they don't have enough energy.
But like you can make them have enough energy
by heating them up.
Oh, okay.
Then colliding particles with more than activation energy will produce a chemical reaction. So this kind of collision is called an effective collision. So
okay,
the collision will achieve this. When this is achieved, they will break their existing chemical bonds in the reaction.
So they can rearrange.
Yeah.
Oh, I
So,
see.
which means the EA, right, the activation energy is dependent on how strong the bonds are.
Ah, oh yeah. So like, because it needs to break the bonds, right?
Yeah, so if the reactant A and reactant B, the reaction the bond is weak, right? Then your EA will be low. EA, when EA is low means you
Very fast.
reaction.
Yeah.
Very easy to get effective collision. If the bond is stronger, right, then the EA, the minimum EA will be higher.
I see.
Then
Okay.
then you have to have more energy for reaction. So there is higher chance of getting an ineffective collision. But you still want the reaction to take place, so you have to play with the factors to make sure that reaction takes place.
Okay. Whoa.
They just hit each other.
But then what if you don't hit each other but hit your own?
Then you just bounce off each other again.
How come you bounce off now?
If you tell me circle hit with circle, but circle and circle is not supposed to have reaction, right? So they will just hit already, then after that, then they will
So
just
just
go
hit
off.
again and again until hit the square.
Because you know that there's constant random motion inside the flask of reacting particles.
Yeah.
So they are always moving, so they're always colliding with someone.
So eventually they'll collide.
They will eventually collide with something with the thing they are supposed to collide with, and then form a chemical reaction with. They form that kind of thing. So if you increase the frequency of collision, means you will kind of increase the chance of having effective collision.
Okay.
It's like,
for the speed of reaction increases.
yeah. So if you want to increase the rate of reaction, that means you have to increase the collision between particles. So when you increase the collision between particles, then higher chance you get an effective collision.
Oh, because they're like bouncing very fast.
Bouncing very fast. Yeah. So you will happen that some collision pair will have energy more than EA. So it's very much like you want to do certain thing, but you always cannot get it. Then after that, then you say you must always try. Because when you try, you'll get a higher, then you get more chances of getting it. If you don't try, totally don't need to do it.
Yeah, that's true.
Yeah, same logic.
Okay, so interesting. Whoa, that's a lot of stuff.
The first four: concentration, pressure, particle size, temperature. Catalyst, good to know it exists, but I think it's not in your syllabus, so they will not outrightly test you without you knowing it.
Okay.
They can be an asshole. They give you information about it, then they test you.
Oh. Huh? How they test us about it?
It's like this. Certain questions they like to say, give you one sentence, two sentence in front, the structure questions. Then they say, oh, so and so, what is this thing? Like just now we have this question.
Oh, the graph?
The graph, right? Okay, but you see the question down here, they give you this. Then they tell you you can measure the speed of reaction by using this formula.
Oh.
So they give you this piece of info, right? Then after that, then they ask you to use this piece of info to solve whatever you're supposed to solve later. Right? Yeah. So you can always have a question, okay, like this, right? The factors are the first four that you learn. Assuming that you totally have no idea about catalysts, right? Assuming then they can they can, as part of a question, they say a catalyst can also be used to increase the rate of reaction of the reaction stated above. Then after that, the kind of thing they will write this. Then after that, then maybe they say it acts in the same way as maybe say concentration. Maybe anyhow whack Okay, so then after that they give you that two line. That means they are giving you the info about how the catalyst work. Okay, then after that, then the next line they say suggest what will happen if the above reaction is repeated with a catalyst.
Oh, okay, I see. So like
that means, right, they gave you the info.
They gave us the info. Then they
ask you to apply the info.
But it's easier than just outright catalyst questions usually, right?
Yes, that means they will give you some help.
Okay.
You know what I mean?
Yeah.
So this is more like an application of the knowledge that you are given. So that means you do not have, even if, because if they test you about concentration, pressure, and particle size and all this, right, they will not give you help, and they will just ask you explain in terms of concentration why the reaction became faster.
Okay. I see.
Whereas if they have not taught you, well, catalyst or something else, right, they will give you that piece of info, then they ask you about that, and it will go around that info that they give you.
Okay.
That is still possible and within scope.
I see.
Yeah, because certain times, right, students ask, my 老师 give me something out of syllabus, why I mean, never learn catalyst, why test us? Yeah, example lah. But the thing is, they have already given you the info, so they did not require you to know about catalyst before the exam.
Okay.
So it's considered within scope. It's not testing you out of the blue, they're testing you application.
Okay.
Yeah, so there are 5 of them you need to know for. The last one, just know for the sake of knowing, because you never know it will appear or not. And anyway, I never include much, I just include some background info only, that's all.
Some basic one.
And
Okay.
you never know what will happen, huh?
Yeah.
So the factors, these 5 factors, right, affect speed of reaction because they either impact or affect the number of collisions per unit time. That means they increase or decrease the number of collisions, or they increase the energy of the collision.
Energy
means the energy of the particle, energy the particle have when they are colliding.
Oh, okay.
You remember just now I say that if there is more, the particle has more energy, then you will collide, and then more effective collision will happen because they have higher energy, they have higher chance of hitting the minimum criteria for the reaction. Yeah, that's what I mean. Number of collision is if you collide, increase the factor will increase the number of collision. Number of collision increase means there is a higher chance of getting an effective collision. Yeah.
I see. Okay.
So you have concentration. Low concentration means there's lower number of reactant particles.
Oh, but then if there's more chance of them colliding.
So higher the concentration of the reactant means the greater number of particles is per unit volume. So in that one, then because there's the number of particles per unit volume increase, right, means the number of collisions per unit time will increase.
I see. Okay.
Then because number of collision per unit time increase means there will be a higher chance of having a higher frequency of effective collision. So then the greater is the rate of reaction.
Okay.
Which this is written like that, and you can copy wholesale and throw into your answers.
But must be in order.
In order.
Does it matter?
Is in order. You can't have the greater reaction already, then talk about higher concentration.
That's true. Okay.
So you can copy this wholesale, throw into the answer. The thing is, if they talk about a certain reactant, right, then you have to rename your particle names.
Oh yeah, because if they give us a specific one, right?
Yes. You cannot just wholesale copy and the 老师 will say, oh, you just lifted from the book.
If I can remember, it's good already. What?
The thing is, what they want is you know how to apply your info. They want the application. So the emphasis of applying knowledge is greater than regurgitation.
Okay.
Yeah.
So must learn how to apply.
Yeah. Concentration. So they always give you that kind of question, that kind of reaction. That question where they, oh, I have two graphs. One has factor A and one has factor B. Then factor A, factor B, when I plot the graph together, they look like these.
I see.
So you have the factor 2, graph 1 and graph 2. So the graph with higher concentration will show a steeper gradient.
I see.
So reaction 1 has a steeper gradient, means reaction 1 has higher concentration.
So will they like give this kind of graph, then ask which one has the higher gradient?
They ask you which one has higher concentration. They
Okay.
won't ask you gradient because they'll ask you higher concentration. So when you ask you for higher concentration, then you must know that the higher concentration graph has higher gradient. So
Okay.
then you go and pick.
Can, I think.
Uh-huh.
Yeah. It's just the steeper one lah, because
The one with the higher higher factor will have steeper graph. Because higher concentration equals a higher rate of reaction. They say already,
yeah. What is this?
pressure.
Oh, this one for gas only.
For gas only, pressure has no effects on reaction that do not involve gases.
But how would you measure this one?
You see how fast the product is formed. Okay. Pressure is force over area. Sec 2, Sec 1 science.
Yeah.
Yeah. So particles like this, right? They are present and then they will collide with the walls of the container and then also collide with themselves, right? So when they collide with the walls of the container, they will exert a force. And then if you look at it over a certain area, then that becomes pressure. A certain volume like this, right? The particles are further away from each other. So then the chances of them, because they have more space to move within that empty space, right? That space, right? So they will collide with the walls of the container lesser. So then that means the force exerted on the container is lesser, then pressure is lower. Yeah.
So high pressure makes it faster as well, the speed.
High pressure means you force the volume become smaller. There are two ways to increase pressure. One is to squeeze them so that the volume becomes smaller. Once the volume becomes smaller, the particles got no place to move. So they will collide with each other more. They will also collide with the wall of the container more.
If they collide with the wall, then it creates pressure.
The collision between themselves and collision with the wall will create pressure.
Okay.
So when the volume is big, collision is lesser. When the container is small, right, particles remains the same, right, then they collide with each other, more pressure is higher. So when they say increase pressure, it means it will reduce volume, cause the separation of the particles to become lower.
But what's the other way?
The other way is you take this container, which is the exact same volume. Down here maybe say got 50 particles.
Oh, okay.
So the same volume, you increase the number of particles to 100 because the increase in the number of particles will make that that means the space is the same, but you have 100 particles trying to fit in.
So be like the other one also.
Yeah.
Okay.
The collision will increase because they are very close to each other. Yeah, but in chem, I think most of the time when we talk about pressure, right, it's always reducing volume. Because your reaction, it doesn't make any sense for you to increase pressure by increasing the number of reactants, the amount of reactants, because in the amount of reactants will affect your amount of product, which you don't want.
That's true.
Then they say when you increase the pressure of the gaseous reactant, right, means the volume becomes smaller. The volume becomes smaller means there's a greater number of particles per volume. So then the greater number of collisions per unit time, like I explained to you just now. So the higher the frequency of effective collision. If there's a higher frequency of collision, right, effective collision, then the speed of reaction will be faster. And again, you can copy this wholesale.
Just need to add the what gas.
You edit a bit lah.
Okay, can.
Then this is whatever I was saying just.
Wow. Would they decrease the pressure and then ask?
Can. It's the reverse only.
Yeah, I just asking, curious.
It's how they phrase the question, whether they want to phrase the positive way or the negative way. Positive means your answer will become a positive result. Yes. Then the other way, negative phrasing means you will get a no as an answer. So same goes. They'll give you two graphs and then you are supposed to examine which one is the higher pressure, which one is the lower pressure.
Whoa.
So obviously one is the increased pressure one. Because the rate of reaction is higher. And if they ask you why one is higher, that means it's steeper gradient. So
the speed of reaction is faster.
Yeah, so then it must be from the reaction with high pressure reacting in the system.
Okay. How do you change this?
What you mean?
Particle size. You can change this.
Can you have two setups? One in big blocks and one in powder form.
Oh.
So it's big piece, small piece.
I see.
But some people have a problem with understanding why the smaller piece have higher surface area.
No, I think I understand.
It's very much just when you make it smaller, more of the solid particle gets exposed.
Yeah, but it will still react, right?
More surface area, right, means there is higher area for the solid reactant, right, to come into contact with other liquid reactant particles.
Okay, I see.
So that means those surface area are exposed to collision. So a bigger surface area exposed to the collision, right, means higher chance of having frequent effective collision. They say the larger the total surface area exposed to collision, the larger the number of collisions per unit time. Then that means the higher frequency of effective collision. So the speed of reaction is faster.
So okay, that's cool, I guess. Yeah, but if it's a powder form, how would you make it collide? It's powder, it cannot move.
Powder form simply just means the particle is smaller, but then down here got atoms kind of all everywhere, and then your other chemical X, the atom will come in.
So the other one is the one moving.
Yeah.
Okay, I see.
If there's a problem with particle size and surface area.
Oh, that one's
in cube form. But if you already know, right, then you can ignore this slide. This one, same thing.
Yeah.
The graph one will be steeper because the rate of reaction. Graph one is a smaller particle size one, because smaller particle size means greater surface area. Greater surface area means greater collision, so greater reaction. You will notice that all your four factors, right? The explanation is all the same one.
Oh yeah. The same idea, right?
Yeah, yes. That means it's either increasing the frequency of collision or you increase the activation energy. So your concentration, your particle size, and pressure all increase effective collision. So you will just say that, oh, because increased pressure, then that means you will have higher number of particles per unit time. That means collision increase already, then the rate of reaction increase. It's the first two sentences is different.
But the
then
rest
after that is the same.
Yeah. Whoa, temperature.
Temperature got two things down here. One is temperature when it's higher, right? That means the reactant particle have higher energy. They will move faster. Kinetic particle theory, they move faster. So when they move faster, they will tend to bang into each other, collide into each other at a higher rate. So the frequency of collision will increase when temperature increase. Energy from the heat, yes. Then it has a second factor because the temperature will allow the particles to have a higher minimum energy because they are moving faster. Means they have energy, right, higher than activation energy. More of them will have energy higher than that. So when you have faster particles and have more energy, when they collide, it means that a higher percentage of them will make an effective collision.
I see.
So when that happens, right, then the rate of reaction becomes faster. So temperature got two factors. One is this one, number one, and this one, the activation energy one. So concentration, pressure, and particle size have the same explanation. Temperature have to explain these two factors. Temperature got one more line.
I think this one is the more things to remember.
So when you remember that three as one package. Temperature, put one side and remember separately.
Okay.
Then the blue box, it's just telling you that you increase temperature means the rate of reaction will double.
Oh, every single reaction?
10 degree increase, right, will double the rate of reaction.
Wow.
Usually.
Then temperature really increases a lot then.
Temperature increases a lot. That's why I tell you, you got nothing. You can't, if you have a slow reaction, remember all your metal acid reaction, metal and water reaction.
Yeah.
So the thing don't react, right? So what happens is you will heat up the metal and the acid, or metal and the water, and then the reaction increase very significantly, right?
Yeah.
So that's why temperature is high factor.
Still the same, yeah.
Same.
It's just the front lines are different. Whoa.
If worst case scenario, you need some summary and you already know the rest of the rubbish, then you just take this one.
Okay.
So which also means that concentration, pressure, particle size, you explain the frequency of collision.
Mm.
Temperature, you have to explain both. So depending on how you understand and how you memorize, you can reduce the amount to memorize.
Okay.
Yeah. If you understood a lot, then you memorize less. Because when you understand, then you can generalize which one to memorize, which one not to memorize, which one is the same. All of them are the same, don't have to do.
Okay. But the only thing I really need to memorize is the temperature. Because the other three is kind of like common.
Yang.
Yeah. What is
And
the
it is good because all of them look the same, so it's lesser on the brain. The yellow one is highlighted because MCQ question, love this question a lot, love this scenario.
Really?
The old MCQ questions, you will see this a lot. Like they will ask, they will say, oh, you have this mine, you have this factory, and whatnot. Then after that, they say they will have to pay attention to their flour or the coal dust or chili powder, curry powder, whatever powder they can have, all in powder form. Then after that, then they'll say the factory caught fire.
Oh, then ask why.
Yeah, why? What is the cause of the problem? Or they ask along the line, it's always that then it's because the particles are very small. The dust particles are very fine. So then because surface area is damn high, so once ignited, right, the rate of reaction is very fast. So the reaction is very big.
Then I didn't know flour is highly combustible. It's like, is it?
You have to trigger it. But in Singapore, it's quite difficult because the humidity is very high.
Oh, I see.
That means you have flour absorbs the water. Then you want to heat it, you want to burn it, it's going to be a little more difficult. I think these highly combustible areas are all the very dry areas.
Not Singapore lah. Singapore not dry. Then food in refrigerator is also speed of reaction.
Yeah, you put in fridge, temperature is lower.
Oh, okay. Didn't know that counts. That's cool.
So application of rate of reaction.
Okay.
Pressure cooker.
Pressure cooker also. That's more than I thought. C, big size. Yeah. Okay. C3 possible. What do I know?
Increase the concentration of the
temperature.
HCl. Increase the temperature.
Particle size
of the manganese oxide.
Right, because pressure cannot.
Pressure no hope here.
Is it?
Warm the hydrochloric acid, powdered manganese oxide, higher concentration for higher hydrochloric acid. Is it possible for me to increase the concentration for manganese oxide?
No, I don't think so.
Because it's a solid, huh?
Yeah.
Pressure not involved on here because there's no gaseous reactants.
Only the reaction. The product is gas, right? Gradually decrease because the reactant is used up, right?
As the reaction progresses, manganese oxide and hydrochloric acid gets used up. Then all our change to products, so you got no more.
Do I need to say the change into products?
You can say it's used up, it's fine.
Oh, used up, okay.
Why did the reaction finally stop? Wow, this is damn obvious.
The reactant is used up. What else can it be?
Completely used up.
Under which magnesium react the most rapidly? Powder, right? Powder and D.
Powder, high concentration, higher temperature.
Will the speed of reaction increase? Pressure. So it must be gas. So C. Okay. Which of the curves could be obtained by the steep one? So curve 2.
Yeah, so obvious, right?
Oh, I need to
explain your answer.
I don't know. Explain. Cannot explain. Wait, no. It's just because temperature. Temperature is kind of hard to like at the higher temperature the speed of reaction will be faster. Then curve 2 has the steeper gradient, which means that its speed of reaction is faster than curve 1.
But they already tell you, do you know?
Tell me what?
No, you have to relate lah. If you talk about the gradient
relate.
and all that, then it'll be fine.
I have to. Oh, okay.
You have to say curve 2 has a steeper gradient, so then curve 1, then curve 2 is obtained from Then if they want some more, then you give them some more lah. So if they probe you even further, like ask you about in terms of something else. Now you see this one, like in terms of something else, they'll ask you to explain.
In terms of collision theory. Oh, this one's probably really long though.
So you see, right? So temperature increase, Ke of the particles increase. So the collision, they collide with a more powerful force to achieve the activation energy. That leads to effective collision, more effective collision. So, and they move faster and collide more frequently, so the number of effective collision also increase.
Okay.